The time officially starts 5 minutes.
Yes, so hello, I'm Chuck. If you haven't been to my talk yet, it's always the first slide is most important, especially this time because it's going to be very fast and there are a bunch of links that I think you may be interested to check it out. So please take the picture of this slide and then get that link and then you would get everything here. So what is CRA and how can it, I will always drop a bomb, right? I would say it could have potential to destroy open source ecosystem. Woo, spooky. So what it is, let's jump into it. So I'm Chuck. I have already introduced myself two times. I'm not going to do it again. So come to find me, get stickers. So what is CRA? So CRA stands for Cyber Resilience Act. So it's a security thing, right? It's a good thing. But what is it? Remember GDPR? Who is still eating this cookie of GDPR? I have to click accept. Yes, no? You remember? Do you know what is GDPR? Yes, okay. So now we have CRA, Cyber Resilience Act, and because I only have 5 minutes, I can't read out the whole CRA to you, but to put it very, very short, it's kind of like putting a CE on, because you know, when you, for example, buy a kettle here, maybe you don't use kettle here, I don't know, like when you buy a kettle here, then it has this logo on it, means that it's safe, right? It kind of complies to some of these regulations in Europe, and Europe, you know, is one of the safest place for consumer because I used to have a friend back home in Hong Kong, and she worked in a laboratory, and then do some chemical testing if things are safe. She said the EU standard is the highest, so good for us. So it's a good thing, right? Like we are protected. Our software is also protected now, so is it good? Yes, but we are all software developers, I hope, or you use software, or you contribute to open source, or you use open source software in your work. So in open source, things are a little bit different. Look at this picture. Are you that person who is maintaining that little small thing that everybody uses? And basically, that may be a person who do it by themselves, right? One maintainer maintaining it for everybody else. It could be, because how many Python project that you're actually using, and it's have you checked all the dependencies? There may be something that is not famous, nobody knows about, but everybody uses it. It's so important. Yeah, so the problem is that if it's a project like that, it may be used by everybody, but they have no resources. They just try very hard to maintain it in the weekends and sacrifice their life and time and ability to earn more money. They can't really spend more time or hire someone to make sure that it's compliance. So, but then are you going to kill open source? That doesn't make sense. Yeah, it doesn't make sense because that's not what they are trying to do. They are actually trying to get those big guys who is big company who, distribute some, software, and then if they have money, they hire a lot of people. They should actually hire someone to make sure that it's safe and make sure that all the security problems are fixed and patched, and so they're trying to add this non-commercial activity exempted. So if you have read it, there's some exemptions. Are we safe? It's very tricky always because lawmakers sometimes they write things down, and then that's why every law is taking a long time to be made, and there is always an amendment because there's always something that you can debate about it, right? There may be some lawyer who found a loophole or something that the big guys will get away and catch us instead, which is very, very scary. So, for example, some of these concerns I may have is that if I am a foundation, like Python Software Foundation, can I accept donations? Does that count as commercial? So what about, I use open source project in my, in my work, and then it become a commercial product, is it okay? And will my employer, or you are an employer, you hire someone, then will you allow your employee to upstream and contribute back to open source? Will you be, responsible for that software if something happened? And also, can I, if I want to start a startup, I have an open source product that I put out there for people to use. Can I use that to monetize and have some cloud service? Does it count as commercial? Millions of questions. So, what should I do? This is what I'm doing right now. I'm getting more information and I'm telling people about it. And also, I joined this group. So this is the name is a bit catchy. It's Open Forum Europe. So this is a lobbying, they have a task force, a CRA task force. There's a lobbying group that gather all of us to voice our concern to the parliament members. So you can do that as well. You can read all these things, right? And then or join our panel session at EuroPython. Thank you.
Great. So time start.
So hello everyone, my name is Piotr and I'm building data science tools. And one of the tools that I created is called Mercury, and it is a framework for converting Jupyter notebooks to web application. And there is a huge problem with sharing your work if your work is done in Jupyter Notebook, because you cannot send the Jupyter Notebook by email, because other person need to have special environment with Python, with special packages and so on to use your notebook. And that's why we created a Mercury Framework. And I will show you. So here I have an example notebook, okay, and this notebook has several widgets, okay, and you know it is a standard notebook, and I can run Mercury locally. Mercury run, and it will start a Django server, and the Django server will serve our notebooks in the directory as web apps, and you can select the notebook, the application, and all your code will be hidden, and only output will be displayed, and you can play with it. But I would like to show you how you can easily deploy this notebook to the cloud. So we created a Mercury cloud service where you can upload your notebooks to create a website, and I will show you right now how to create a website. So it is very simple. You need to set the title, you need to set the subdomain. You can choose from several domains. You can say hi PyCon.pl, and you just click OK, and we have the site running. So it only displayed the hello message. Let's upload your notebooks. So I have few notebooks created, and I also upload the requirements text file, because all required packages will be installed for you on the fly when you open the app, and you just click OK, and you can go back to the site, and all your notebooks are online, and you can share the link to your notebooks. And if you know any solution that is faster for deploying notebooks as a web app, please tell me, and I will buy you a beer. Thank you.
Yeah. So we're good to go. Start.
Okay, so hi, my name is Ivers. I want to show you the hidden Celery message broker. So, who uses Celery? So, I assume everyone knows what Celery is, so it's a kind of default task queue for Python. So, but Celery on itself, it doesn't do that much. It likes to delegate a lot of work to different kind of backends. It has a backend for storing results, and it also has a pluggable message brokers. So these are the brokers that are visible on the Celery, in the Celery documentation. So who of you uses RabbitMQ? Okay, so I think the RabbitMQ was the first and only one message broker that was supported by Celery version 1. Who uses Redis? Okay, anything else? Amazon SQS or? Ah, nice. You might be my friend. Okay, so, and I trust you. Let's wait for a moment. Do not spoil it. So, but the Celery itself doesn't kind of support all those brokers. It instead uses library that is also hosted on the same Celery GitHub, so it's called Kombu, and it has a list of more brokers that it supports. There's even like MongoDB and some kind of in-memory. But there's even more if you go to the API documentation of Kombu. And what I want to focus is on this SQL Alchemy transport model, which is already built in. And by the way, the one above it is file system transport as well. So that should be maybe a topic for another lightning talk. But so this SQL Alchemy transport model, if you click on the link, it doesn't show you much. So you have to go to the source code. Oh, and by the way, this transport is there for more than 10 years. And it got some fixes and updates along the way, so it's not like it's completely dead. And if you go to the source code of it, so there's the documentation string that it basically uses SQL Alchemy as the message store, and the way you configure it is using this SQL Alchemy. So is this the same way that you use SQLite? Yeah, great, you are my friend. So, and since I discovered this, so all Django project I usually start with this string, where the Celery broker is a link to SQL Alchemy that uses Postgres. Well, I prefer Postgres in most cases, not SQLite. And yeah, so this is my starting point, and so far I haven't faced any issues with that. So if you want, try it out, and hope it helps you to minimize the infrastructure size.
There's also Django broker that uses Django RM.
Yeah. So thank you. That's all.
Thank you very much. Let's go.
Okay, awesome. Hello, PyCon-PL. I'm Mateusz. I work at the Warsaw University of Technology as an assistant professor. I'm also a professional musician, and I work mostly with musical AI. So music is difficult for AI for a number of reasons. Unfortunately, musical AI is also difficult for its users, also for a number of reasons. And there's a bunch of ideas. What can we do with that? So idea number one is we can make the AI to work in this fashion. So here's a text description, and we want to generate music that fits that description. This is the thing that we do with images, that we do with text, etc. And the idea number two is like, I've got a bunch of music already, and I want to generate more stuff that's similar. Okay, so let's take a look at a few goodies that allow us to implement and use those two ideas, and that we can already play with. So first of all, there's this model called MusicalM. This is from Google. This is from January this year. It's, you know, like a modern neural network, so it's pretty complicated. It's like 3 neural networks glued together. But what it does, it generates music according to a description. So you've got the main soundtrack of an arcade game. It is fast-paced and upbeat with a catchy electric guitar riff, etc. So, I mean, that's a pretty abstract and high-level description, right? I'm gonna leave it to you to listen to this. But basically, the model works. You can play around with it. What it does, it generates raw audio based on a text description. And how do you play with it? It is currently available through the Google AI Test Kitchen. Another one is called MusicGen. This one is from Meta AI. This was released like 2 or 3 weeks ago in a paper called Simple and Controllable Music Generation. When something starts with simple, it's usually, you know, a trap. But fortunately, the model has a pretty good demo on Hugging Face spaces. You can play around with it, you can try it out. So Music Gen from Meta AI, what does it do? It also generates raw audio music based on text description or on melodies. This is a difference from the previous one. Can I play with it? Sure, you can try it out in Hugging Face Spaces. Also, the code is open sourced on GitHub, and you can train your own one in Google Colab. There's Rave, which is a variational autoencoder for fast and high-quality neural audio synthesis. This is probably my favorite one. What it does, it takes a bunch of audio, compresses it into a latent representation, whatever that would be, and it allows you to produce more audio like that. And it also kind of remembers the structure of your music, so it kind of encodes your audio in its temporal dimension. So you can train it to produce more Darbuka, or you can train it to produce more Beethoven, or you can train it to produce more of your voice. So Rave, what does it do? It generates raw audio based on some input, and it does it very fast. Can I play with it? Sure you can. It's also open sourced, it's on GitHub, and you can train your own Rave model with minimal effort on Google Colab. And the last one, it's called Dance Diffusion. This is also a recent one. It's a diffusion model, so you may have heard of, about those because DALL-E is a diffusion model, for instance. Stable Diffusion is a diffusion model. What does it do? It generates samples similar to the training material, and you can also train your own dance diffusion on GitHub and Google Colab. So goodies for generative AI music that you can play around with are Musical.ly, Music Gen, Rave, and Dance Diffusion, and that's only the top of the list. I encourage you to take a dive into the realm of musical AI, and you can find me anywhere on the web under the handle Mamodrzejewski. Thank you.
Thank you very much. Let's start.
So, hi everyone, I'm Piotr Grędowski and I work at Orstel, and today I realized that not many of us Python developers know about mutation testing, so I decided that maybe I will try to tell you a few words about it and show how you can do it. So first of all, I will not go into details what mutation testing is, but yeah, in some simple words, it is a framework which is just taking your code, it is changing some constant simple operations like division, it's multiplying instead of division, then subtracting instead of adding some things in your code, and it's checking if your unit tests are failing after such changes. Yeah, for me it was quite impressive when I learned about it. So let's look at our very complicated tests and code. So here we'll look at the code which is responsible for calculating an angle between clock hands. If everybody know what clock hand is, then great. If not, here you have a reference. So our code here, you can see, we are testing that. We are checking what's the angle between 12, at this hour, and it's 0. And let's run tests. We generated HTML coverage, and here we can see that we have 100% test coverage, branches are covered, everything is great. But our code is not, and this is a tool for checking if your code is tested in, let's say, more ways than only checking line coverage and branch coverage. So let's try to make it better, and let's see how how we can find these mutations. We have a mute framework which allows us to create some mutants. Mutants, here we can see that it is creating them. We'll have 22 mutants created. 9 of them were killed, and 13 of them survived. So our code was changed in 13 different ways, and our tests passed 13 times. And let's see what will be some examples of mutants. Here I will try to show 43. So here we can see that we are doing some weird stuff. We are, here we want to use value 30, but we written that in some weird way, in which we are only taking, let's say, whole parts. And when we changed our code from 360 to 361, everything passed. So that is probably something wrong, and we'll change all such operations to, yeah, just a simple division. And probably here I did something wrong, so I will, yeah, change it. Now let's run again mut to find all existing mutants after this change. Here we can see that we had 13 survived mutants. Sorry, not this. Let's wait. Now we even have more of them. That's kind of interesting. So our goal is not to create more mutants, but yeah, to have it less. Okay. Okay, let's continue. But okay, yeah, okay. We do not want to change only this, yeah, what we changed here, this operation, but we also want to write another test which will test something more than, yeah, checking a zero angle. So here, let's test 3 and assert that angle between 3 is, if I recall correctly, 90. Let's check if there will be less mutants survived. Here we'll have information that there are some suspicious mutants. And here in this window you can see how yeah, these mutants are applied to our code and our tests are executed. Now we have only 10 mutants. Also, because my time is running, I will just skip to the moment in which, yeah, I will just check out a tag, which is called end, if I recall correctly. It's unfortunately not. Yes, it is. And here I'm just adding a third test, which is checking another case. And yeah, it is something which improved our tests and our code, and it is something worth trying. Thanks.
Yeah, ready?
Yep.
Great, let's go.
All right, so hello everyone, I'm Łukasz, and I have a question. Do you know what animal is on that logo? Yeah, that's a snake. Do you know what snakes do? Snakes do zigzags, great. And do you know what else does zigzags? Yes, exactly, skiers. I knew that you would figure it out. So I'm also an avid skier. I love skiing. I'm skiing whenever I can. As you can see, if you take a look at a closer look, you'll notice something different about my skis, because there's actually only one, because it's a monoski. And what I mean by that is that whenever I can, I try skiing on strange things. Whenever I can, I'm trying to ski in strange places. Like for example, here this is a shopping mall in Dubai. Literally, this is, you know, you have there's a hotel. The windows that you can see there, it's literally a hotel with a view to a ski resort. Or for example, on leaves. By the way, if you look it up on YouTube, I mean, people skiing on leaves, it's much more difficult than it looks. Anyway, regarding strange places, what if I told you, you know, I mean, we're in Gliwice, and what if I told you that 20 minutes of driving from here is a place where you can ski on a treadmill, a literal treadmill. And another thing, I mean, you get everything. You just pay the entrance fee. They give you skis, boots, a helmet, and even an instructor that helps you make your first steps. And also another thing is that I have a slot booked at 8 p.m. and I'll be leaving at 7:10 or maybe a 7:15. And well, if you're interested in joining me, you're welcome. Well, otherwise, see you tomorrow, I guess.
Thank you very much. Yeah, I think it works. Time start.
Okay, so I have one slide for my presentation, which is that I have a workshop on Sunday morning, and if you're a participant in this workshop, you need to download this particular container image because it is quite big, like 10 gigabytes, and this network will completely fail with doing this. But because I have some time left with my presentation, maybe I will show you what is inside of this Docker container, because actually it is, I think, quite interesting. This is my GitHub page for this. You will find the instructions there, and if you're interested in the whole thing, there is my previous talk on PyCon about this. But inside of this Docker container, there's actually a full-blown Ubuntu. By full-blown, I mean that it is actually like a mint version of Ubuntu, so with a GUI and so on. There is inside the robot simulator, and there is a whole ROS system. So for example, you can see the robot on the map. There is actually mapping going on. You can move the robot around. And even without being on my workshop, you can play with this using Python. So there is a couple of exercises, but they are, I hope that they are instructive even to those of you who will not participate in the workshop. They explain how you can use and move robots using ROS and using Python. Python is a great language. Actually, I had a question today, like, can you really use Python with robotics? And the answer is yes. And most of what we as roboticists do is program in Python, not, for example, C++. It is pretty much like with the Linux system that you have these drivers, right? And they are on a low-level language, but to do actual stuff, you use a language that it is friendly, which is, you know, nice to use, and Python is such a language. There is great community around ROS and Python. I encourage you to investigate it, and maybe we can just move the robot using some Python. There's actually just one command for the robot to go from one place to another place. And this is this command. Okay. So hopefully the robot moves, but if not, it will be the fastest. It is moving here. So I just put the robot on some place on the map, and it is quite hard for the robot to move because it actually needs to know where are the obstacles. And what I did is I put the point on a map using Python. So the robot is actually moving to the corner of the map of this virtual environment. It is a physical simulation, so you can really like crash the robot and see how it, you know, rolls and so on, all from Python. So I hope I encouraged you to download this. If all of you download, I hope that some of you are on the workshop, and I'm winning, because this is something that I'm really afraid that nobody will download, and we will pass the workshop by just downloading this one container. So, thank you.
Thank you. Yeah, I think I can start. So, let's say you're a lazy software engineer, as I am, and well, like if you need to like edit a video or edit an audio file, you'd usually think of like some old software you used when you were a kid. At least this is what I do. I would think of Windows Movie Maker or some other thing. I just don't know how to use these things anymore. I don't know Windows anymore. So there is this tool called ffmpeg on Linux and on Windows too, but the thing is like it can get quite complex. So let's say I have like two very important files which I want to process, which is like I have to switch the displays to okay, no, this is not this one. Yeah, I forgot to set up the whole thing. Now, yeah. So yeah, I have like Baby Shark and Nyan Cat, which are like the most awesome videos you can find on internet. So yeah, I can just import ffmpeg. The package is called ffmpeg Python, available on PyPI. And basically, like, yeah, I will do like cat equals ffmpeg input Nyan Cat. Yeah. And then shark equals ffmpeg input Baby Shark, And now what I can do is, well, let's say I want to embed the Nyan Cat video onto the Shark video. So I just do Shark overlay cat that video that scale. Oh, sorry, it's like filter and then scale. And let's say I want it to be like 200 by 200 pixels. And yeah, I can try to compile this command because like it will just, oh, I'm sorry, I have to do output before. Yeah, output, let's say overlay MP4, yeah. And yeah, like this is my ffmpeg command, I can execute it and hopefully it can run. Yeah, it does. I wait for the streams to get processed and then I can just do, yeah, I have a new file. Let's play the overlay thing. And I guess, is audio working? Oh, it's like the worst. Give me a second. Give me a second. No, this is not this one. Headphones, maybe headphones will work. No, I'm sorry. I won't be able to like, you know, like hurt your ears with this thing. But like, yeah. So unfortunately, the audio doesn't work. But you can see the video. It's embedded. You can do a lot of other fun stuff. I wanted to apply a low-pass filter on the audio itself. It's possible to like do all those things. But for example, if I wanted to like quickly programmatically check a video file and an audio file to like get to know what codecs are used and stuff like this, I can just do ffmpeg probe and then like for example, let's take the overlay file. And this returns like this dictionary of all kinds of information, like of the streams that the video file contains. Like you can, yeah, like you can use it in automated manner to like, yeah, like get to know like what resolutions your videos have. You can easily extract, you know, like thumbnails of videos. It's a nice tool to like, you know, concatenate videos together. And the ffmpeg Python library is, well, it's an excellent tool because like, as you can see here, I'll zoom it in a bit, like this kind of intuitive description generates, you know, like a command like this, which is slightly less readable than like your Python code, because actually you can have like complex filter graphs in ffmpeg like this, like you have some input files, you can process them like independently, then merge them together, for example, like using an overlay. You can have like a huge pipeline of all kinds of operations on audio and video, and this is like quite easy to use. You can even like connect, it's possible to like, you know, connect it to like NumPy or something else and like process video frame by frame. It's an awesome tool. Just like Google ffmpeg Python and have some fun, like make some memes or whatever. Thank you.